Hello guys, today we'll try to understand the lazy evolution or call by need. If you have learned programming language, let's say C, C++, so you go line by line execution. So what we are saying here, don't execute a line of expression which is not really required for your immediately need. So basically what we are saying, delay that one. So in future what will happen, for example, that particular line is not required, you are saving your processing time. If it is, and again one aspect is that if it is needed, in that case you can evaluate and store that in memory. You don't need to re-evaluate the same expression. So it's basically a delaying tactic that helps into the saving the processing time. So let's go to understand the next example. So here if you see right hand side, we have one Scala example. So we are declaring variable x equal to 5, y equal to 6, and then we are putting a lazy in front of that. So basically if you see in this line, it has to calculate. It has to add x plus y and store the value into g. So it will be 11. But here you are putting a delay. You are saying that I have this expression, but I am not wasting my processing time. Let's go to next line. So after that, what will happen? It will print x and then it will assign a value a. Then once you come in this line, here you need to calculate the value because you are storing this value into the final g variable, and then you are printing this one. So in this time, you have to use this expression. So basically what you are doing, you have to look this expression, what is the g value here. I calculate that. Let's say g equal to x plus y. You will calculate 5 plus 6, 11 will be stored here, and then same 11 is going to print in this line. So outcome will be your 11. So what you have done, line number 3, if you see line number 1, this is 2, and line number 3, you have delayed this expression. But think other way around. If let's say for example in future you don't need this line, you don't need this value to be calculated, suppose, then you are not wasting your processing time. So this is your lazy evaluation. Lazy evaluation is something which is in technical term a delay expression or calculation, right, or call by need. If you really require, that time you can call. So let's understand left hand side, there is a machine. The machine you will see there are many components, but we are talking about the RAM, temporary memory, and then we have CPU. This has control unit and arithmetic logic unit. All the calculation is happening here, and we have stored hard disk. So suppose we don't need some kind of so what happens, right? Any calculation you do in CPU. So if we are delaying or we are not using particular calculation, then what we are doing, we are saving CPU time. CPU time. So basically, it is directly translating into the dollar amount. That is the benefit of the lazy evaluation. But downside is that you have to track. So let's say in this example, once you are coming in this final variable, that you have to remember that okay, what location you have to you have written a g equal to x plus y. So that kind of tracking you have to remember. So basically, you have to remember bookkeeping. At what time you are calculating the g equal to x plus y. So that kind of bookkeeping information you have to maintain, right? I hope you understand what is the lazy evaluation. Lazy evaluation is something you are delaying. You are delaying expression. If it is not really needed, don't calculate that one. And one more thing, if you need that value again and again, don't evaluate or calculate that value again and again. You calculate one time, store in memory, and move forward. So you can reuse that one. So that is your lazy evaluation. So there are some advantages. If you go through the lazy concept, there are some advantages. So let's go to next slide to understand some of the advantages. So let's say for example what we are talking about, what is the advantage of the lazy evaluation. So it will reduce the CPU processing time. What does that mean? So we are saying that basically what we are saying here, basically we are saying that the expression which really not required on that particular moment or for that particular execution, right? We have not to waste our CPU time. So that is the one advantage. Again, reuse calculated value. So lazy evaluation, the another advantage is that once you calculate the value, you are using that calculated value in multiple places. Don't evaluate that expression again and again. You have already calculated value, let's reuse that one. So that is the another advantage. So what is the benefit of that? Cost reduction. Definitely, if you are not using your brain, and brain have dollar amount, so that you are saving your cost. So that is the third advantage. Fourth advantage is the large data set you can easily process. You have, let's say, megabyte or maybe a terabyte of data or maybe gigabyte of data. So what you are doing, you have let's say 10,000 line of code. So what you are doing, you need just 4,000 messages from the first. So you just load those messages and then you can process. So that way you can process more data set. Next advantage is that it reduces the circular dependency. If you go into Java and other languages, right, you will have object have circular dependency. So if you declare something in A object that is dependent, that is has impact on B, you have to make sure that kind of dependency on the Java object. Or you are deploying something in the, let's say, microservices. All the object you have to deploy. So those kind of circular dependency you can remove in the lazy evaluation. Now there are some disadvantages of the lazy evaluation. Let's say last slide we talked about, we are not sure about the memory usage. So basically what will happen, let's say for example we are delaying that expression and maybe after some line we need to recalculate that value. So we have to evaluate how much memory we require. So that kind of disadvantages will be there. And also bookkeeping, because we talked about, right, bookkeeping we have to make in remember, okay, what line that expression got declared, what kind of value it has to calculate, or these kind of reference you have to remember. So basically you are increasing a space complexity. So that is the disadvantages. And also for a developer, so or debugger who is doing to debug that code, he have to understand, okay, what line that expression got declared and which line we are actually using that one. So all these kind of reference we have to remember during the debugging. So debugging, generally, if you go line by line expression, that is very easy for the debugging. You will understand, okay, previous line what was the value, now next line what is the value is coming. But if you are going from the lazy evaluation, so you have to track all these expression in go backward and understand, and then you debug your problem. Coding will be little harder, so because you have to make sure that at what line you have to use the expression and previously which line you have declared that kind of details. So all these things you have to remember. So that's where the coding is little bit harder. Okay. So this is the one of the example we have taken here. One again Scala. So if you see that we are declaring a list 1, 2, 3, 4, 5, and we are saying this print a value. We are multiplying this list by 3. So you will have 3, then 6, 9, 12, 15. So this is the value. If you use the lazy evaluation, what it will do immediately, it will not calculate these values. If you see, this is the lazy variable, and it is not immediately going to calculate these values. As and when it's needed, that time it is going to calculate the value. I hope you understand this one. Thank you very much.